This is for A2 Pure Mathematics. We're looking at algebraic fractions, and this video is on multiplying and dividing fractions. So when we're adding and subtracting fractions, we need to make sure the denominators are equal, but when we are multiplying and dividing, we don't need to worry about that. The advice before multiplying or dividing, you need to be looking at cancelling out any factors that's appearing in both the numerator or the denominator, because that's going to make your working out easier. What you don't want to do is just start by expanding lots of brackets out, because you're going to end up with really high powers on those polynomials, and it's going to make it really complicated to simplify down. So just a reminder that we never cancel part of a bracket, and we only cancel something if it is a factor of both the numerator and the denominator. So looking at this example once again, you cannot cancel those x's down because you've got x plus 2 on that denominator, and so we can't cancel across a plus. So just a reminder that when you're dividing by a over b, that is the same as multiplying by its reciprocal. And if you're multiplying or dividing both the numerator and denominator of a fraction by the same quantity, it will not change the value of the fraction. So this is the same as equivalent fractions. So we're going to make use of that when we have finished a question. If you substitute numbers into the original question and your final answer, you should be getting exactly the same value out. So let's have a look at this example. So the first thing that we need to do is to try and simplify the fractions. We looked at this briefly at the start of the first video. So to do that, we factorise, and then we cancel out any common factors on the numerator or the denominator. So the best way to deal with these examples would be to keep pausing the video and have a go at working through what the suggestions are, and then play the next bit and see if it matches. If you just sit there and watch it through, you're not going to learn anything. So the way that you're going to learn this is by either knowing what you're doing already, which is great, or making a mistake and trying to work out where that mistake has come from. There's nothing complicated in terms of the individual techniques here, it's just that we're using quite a few different techniques together. So step one is to factorise numerators and denominators wherever possible. So if we do that, it would look like this. When we are multiplying, because we're just going to multiply those numerators together and denominators together, I'm just going to write that again, but without the multiplication sign in the middle. Just when we're doing algebra, we tend not to put that multiplication sign there. So what you need to do now is have a look at that fraction and see if you've got any common factors on the numerator and the denominator, and then you would cancel them out. So when we're looking at that, we've got an x minus 2 there and an x minus 2 there, so they can cancel. I've got a 3y plus 1 here and a 3y plus 1 here, so they're going to cancel, because what it's saying here is we've got x plus 2, we're going to multiply it by x minus 2, and then down here it's telling us to divide by x minus 2, so they're inverse processes, so they are just going to cancel out. The biggest mistake that you can make with a question like this is to take the original question and then just put brackets around them and start expanding. That is the biggest mistake that you can make, because you'll just end up with a really complicated mess, which is why you have to go through this factorising step first. Once you've done that, then it does simplify down your question. I'm going to keep going on about this. So you can only cancel common factors, so we can't cancel those x's, but here we can factorise and these x's can cancel to leave me with x plus 1. And there we have it, and that's the end of that question. So there's nothing left to simplify there, and then you would use that fraction in the rest of the question, depending on what the topic was looking for. When you've simplified your fraction, a good idea is to just substitute a number in. So you want to substitute any values in for x and y into your unknown quantities. So put that into the original question and then into your answer. Because all we have done is simplified the fraction down, these are equivalent fractions. these two, and therefore they should take exactly the same value when it has been simplified numerically. The only thing you need to watch when you're choosing your values for x and y is you don't want anything that will make these 0. So I mentioned that again on the previous video. So we can't have y is equal to 0 or x is equal to 2, because then we're going to be trying to divide by 0, so we don't want to do that. So for example, keep it simple, x equals 1, y equals 2 would work. You can just plug that into your calculator, or you can work it out, put all the working out here just so that you can see exactly what's happening. So that's just putting x equals 1 into this, y equals 2 into this, and then doing the same with this, and I'm getting -3 over 8 out both times, and it just gives you a little bit of proof that you've gone down the right path. So we're going to have a look at this question here. Quite often when students are faced with something that looks like this, they're put off just because it looks a little bit unusual. So what you need to do is focus on what each part of this question means. So this line here means divide. So what I'm going to do is I'm going to just rewrite the question in maybe a format that's a little bit more friendly, rather than having a fraction on top of a fraction, which just looks a little bit messy. We are going to do this question in two ways. The second method is a little bit faster if you can spot it, but I think this way is a little bit easier to see what to do next. So what you need to do with this is have a look at each of those brackets, and you want to get a common denominator on this and then a common denominator on this. So we looked at adding and subtracting fractions in the last video. So you should be able to do this. You should be able to look at this and say, right, well, that is over 1. Therefore, I need to multiply numerator and denominator by xy. This is over 1. Multiply numerator and denominator by 9x squared. And we get this here. I've then got divide in the middle. So we're going to change that to multiply, and we're going to look at doing the reciprocal of this second fraction. And then you want to multiply. Now what you don't want to do when you're multiplying is put brackets around this and expand it out. You want to put brackets around it and just leave it, which is quicker anyway, because then you don't have to think, you're just writing down what you've got. You just make sure the brackets are in the right place. So when we multiply the numerator and the denominator together, it would look like this. So I've got 9x squared from here, and then the 3x squared y plus 1 is from there, and then similarly we've got xy from here, and then the 9x cubed minus 1 from here. So this is what this looks like, and then I can check each of these and say, is there anything that can cancel? Well, I've got an x there and an x squared there, and x squared divided by x does simplify, and that's because I have three things here that are being multiplied together. There's three factors. So we've got a 9, an x squared, and then this bracket, and then down here I've got an x times y times this bracket. So because these are all being multiplied, and that means divide, that's why that is going to cancel, which would take me to that point, and that does not simplify any further. The other way to consider looking at this would be to try and eliminate the denominators that we've got in here. So it's kind of looking at it and saying, well, what is it that I don't like about the way this looks? And I don't like the fact that I've got a denominator on the numerator and another denominator on the denominator, and it just makes it look very messy. So what can I multiply? So this is just doing equivalent fractions. What can I multiply the numerator and the denominator by to eliminate the 9x squared and the xy? So if we look at this here, so I've got 9x squared y. I don't want to go with 9x cubed y. It's again looking at a common denominator between those two. So if we've got 9x squared, that includes the x. That's going to cancel down with the x, but I need to put the y in there. So you're going to multiply that through, which would take me to there. So then from this point you would need to factorise it. The reason why we had to multiply this is because I was trying to eliminate that xy. So when I multiply 9x squared y with the 3x, I get this term here. When I do 9x squared y with the 1 over xy, the x is cancelled with 1 of the x squared, and the y is cancelled just to leave me with 9x. That's what's happened there. Similarly down here, the 9x squared is cancelled just to leave me with y. So at this point then you would just factorise that out. and simplify it down, and there we have it. So we get to the same answer. Either method is valid. I think, like I say, this first one is a little bit quicker to spot, but it is worth just considering equivalent fractions. Just what is it you don't like? Try and get rid of it. So looking at this question, the best way to go about this would be to pause the video and to have a go. Okay, so you want to do the reciprocal of this with multiply. We need to factorise anything that we can, and then you want to have a look at simplifying things down. This term here is going to need a little bit of thought, so I'll talk you through that when I get to it walking through this. But pause the video and see if you can start the question. Remember, you learn by making mistakes, so you'd be better to have a go at it and get it wrong and try and work out why it's wrong, rather than just continue to watch the video. So it goes to multiply, and I've done a reciprocal, so I've got x squared plus 4x over x squared minus 8x plus 7. And then we can factorise each of those down. Okay. Now I said that this term needs looking at here, and it's to do with if you factorise out a minus 1. So if we take minus 1 out of that bracket, then that is x minus 1. But we've got a squared here, so everything needs squaring. That squared at the moment is round all of it. So if I add the squared into this, that minus 1 squared is just plus 1. So what we end up with is x minus 1 squared on the numerator. That's a little bit of a tricky one to spot. Now what you'd probably do is get to this point with 1 minus x all squared, and then when you're trying to simplify things down and cancel things down, you maybe see that you've got this x minus 1 here, but you had 1 minus x, so it maybe would prompt you to just have a look into that a little bit closer. So we have got 1 minus x all squared is the same as x minus 1 squared. If that didn't convince you by factorising it out, just expand both of them. And you'd be able to see that that's what it comes to. So then looking at this, we can do some cancellation. So that is going with that. So we've got x minus 1 squared x on the denominator as well, and then I've got an x plus 4 is cancelling down. So I've got x over x minus 7. If you substitute number into x in this original question, it will need simplifying down to get the answer in its simplified form. If at this point you've left it as 1 minus x, when you substitute a number into here, you should recognise that you've still got a fraction that needs simplifying down. Now, if you've got a numerical value that needs simplifying, that means the algebraic fraction wasn't in its lowest term. So that might prompt you to look for something like this as well. Okay, so when you substitute your numbers in, if we substitute it into here, we would get something that can't simplify any further because the algebra can't simplify further. But in here, the numerical values will still have room to simplify because I've got this common factor that I've missed. Okay, so that's just something to bear in mind as we're going through.